All right, 8c. Let's have a look at this. Again, start way over on the left here to give myself some room for everything because it looks like I got some factoring coming up here in the next couple questions. The numerator here, 2x plus 3, that can't factor. There's nothing common there. The denominator, though, has a common factor of 5, so that's 5 times x minus 5 plus, okay, the numerator here, x minus 4. Okay, not much I can do with that. Okay, that's as good as it's going to get here. But my denominator here, now, the denominator is kind of written in a backwards order here, so I'm just going to write this up here. The denominator is x squared minus 9x plus 20. See, that just makes more sense to me to write it in that order. And I can do that, okay, because order doesn't matter with addition. Now, I know someone might say, well, wait a minute, there's subtraction there, and order does matter. Well, yeah, but if you think of that as adding negative 9x, then I can get around that issue of order, and that's what I've done here. Now, to factor that, I'm looking for two numbers here that multiply together, whose product is 20 and whose sum is negative 9. And in that case, I think it's pretty clear that that's minus 5 minus 4. I want to sum these two together by finding a common denominator. But before I do that, and this is a prime example of why, for some of you, if your default thinking here is simply to multiply those together immediately, you're making this harder on yourself. Notice that the x minus 4 that is common in this expression. So now this becomes 2x plus 3 over 5x minus 5 plus 1. Okay, because remember, x minus 4 divided by x minus 4 is 1. Okay, the x minus 5 here is in the denominator. So this expression is equivalent to this one. I make it equal by including the restriction as long as I don't let x equal 4. Now, I'm not done this question. I still have a little bit more to do here, but it has gotten substantially easier. Now I can see that the denominator is quite simple. There's a common x minus 5 factor, and then there's this additional factor of 5 here. The first expression already has everything it needs. This second expression needs an additional factor of 5, so I put it in the numerator denominator. Okay, again, with the understanding that x cannot equal 4. That restriction has to hold through. If I stop writing that, it's no longer equal to the original. So because I have canceled out that x minus 4, this x cannot equal 4 has to stay there for this expression to be equivalent to the one above it. And now let's keep going here, and at this point we're just combining like terms. I end up with 2x plus 8 over 5 x minus 5 with the stipulation that x cannot equal 4. Now, in this case right here, just to be clear, I know that I can take out an additional factor of 2. I know that I can do this, and this will become 2 times x plus 4 over 5 x minus 5. With the stipulation, again, that x cannot equal 4. However, that doesn't get me anything. Nothing else simplifies, no other terms divide out. So really, whether you leave it like this or like this, one is no better than the other. If the question says to leave in fully factored form, well then you have no choice, you have to go here. But in terms of simplification, factored is really no more simple than the other one, the other form here. However, I do have to include that one other restriction here, that x cannot equal 5. Okay, remember we get that from, well, we're told to do that, to list all the restrictions.